matrix equations. Here's the last part of this section 2.6 about the inverse of a matrix, matrix equations, and what we're going to do with them. We're down here. You can write a system of equations using a matrix equation. It looks like this. That all these are matrices. A is a matrix, X is a matrix, and B is a matrix. Now what these look like, A doesn't necessarily have to be a square matrix. It's really whatever size that system starts out to be. Then this X, this matrix that's represented by a capital X, that is one column of the variables. Whatever variables there are, they're going to be in a column here. We're going to pull one apart here in this first example, and then I'll show you where all this comes from. And this B, those are the, see how it says equals B? This matrix is going to be a column matrix of one column, and it'll be the right-hand sides of the equations. Right, so let's check this first example out. It says, here's this system, and it's not a square system, so that's fine. This is like a 2 by 3, because there's two equations with three unknowns. Alright, given this system, we're going to do parts A, B, and C. A says to write the coefficient matrix. B, we're going to write the augmented matrix. Let's just augment it with the right-hand sides. Excuse me. And then we're going to write that system as a matrix equation. So, let's start with, I'm actually going to stick part A right here. I think I can do A and B over here. A is the coefficient matrix, alright? Just the coefficients here. It doesn't include the right-hand sides. So I have two equations, so I'll have two rows. First one's a 7, that's a -2, and a -1. And that second one is a 1, a 6, and a 0. There's no x3 down there. Right, that's the coefficient matrix. Pretty easy. We've done those before. We did them a while ago. Alright, part B, same thing, augmented. This augmented matrix is going to be augmented with the right-hand sides. We've done those. So you start with your coefficient matrix. And we're going to augment it with the right-hand sides. There's a 4 and a -1. Alright, that's the augmented matrix. I'm actually going to put the matrix equation down so I can have a little room. Alright, the matrix equation looks like this. A, in the matrix equation, that AX equals BA, that's that coefficient matrix. It's always going to be the coefficient matrix. So let's pull that off. Here's part C. I should put it up here so I can still see my system. Matrix A, just the coefficient matrix. 7, -2, -1, 1, 6, 0. That's matrix A. Okay, X, that matrix X, remember that's going to be one column. And it is a column of the variables. It's going to be x1, x2, x3. Just like that. And that's equal to your matrix B, the right-hand sides, 4 and a -1. Just like that. That's your matrix equation. AX equals B. Yeah, if you're given any system, you can obviously pull off your coefficient matrix. You guys know about the augmented matrix, but now this is a matrix equation. Now, so let's look at this equation for a second, this matrix equation, and see how it converts back to this given system. If you multiply these two matrices together, A times X, you would do the dot product, this row dotted with this column. You would take this row dotted with that column. So you would have 7 times x1, which is that first one right there, plus the -2 times x2, which is that right there, minus x2, minus 2x2. Then you have -1 times x3, which is minus x3. Alright, then for the second one, you would have 1 times x1 plus 6x2 plus 0 times x3, which is just nothing. Alright, so you would have this left-hand side over here. You have a matrix, a 2 by 1 matrix, which looks like that, and equal to still these two over here. So that first row would be equal to this first row equals 4. That's that whole first equation. Right, you'd have that other dot product we had over here, the second row, equal to a -1, which gives you your system. Right, so that's a matrix equation, and that's how you get it if you're given a system. A system, remember, the A matrix is just the coefficient, so just pull off those coefficients. X is really easy. Make sure you write it in a column. Pull off those variables, and then matrix B is always a column, whatever those right-hand sides are. Right, that's a matrix equation. I don't know why I left so much room. But the way we're going to use them, they can actually, matrix equations, they can be used together with matrix inverses to solve systems of equations. So I'm going to show you one. It's just like an illustration. I pulled it right out of the book. I mean, it's an example that's in the section. If you pull up the ebook, you can look at it. But I didn't want to show this to you. I don't know that I put any in the homework, but I'm going to show this to you. This is how you can use matrix equations together with inverses. Alright, if you look at, let's start with this matrix equation. AX equals B. Alright, to solve the system, you're trying to figure out what those variables are. Remember what those x's are. So, if we could, again, to try and get these x's, it's sort of like solving for x. If you wanted to get the x over here by itself, even though this is a matrix equation, these are matrices, let's multiply by A inverse on both sides of this equation. Alright, then A times A inverse is always the identity matrix. Looks like Roman numeral 9, but it's not. This is the identity matrix, and that's matrix X. And again, these are just two matrices multiplied together on the right-hand side. Now, the identity times any matrix is just that matrix. So if you see, you can solve a system by just multiplying those two together. So if you can find A inverse, given a system, you can write out the system equation. If you can find A inverse, that's going to be the inverse of that coefficient matrix. Then you can multiply it by B, by those right-hand sides, and you'll have your answers. Alright, let me show you one. Need a clean sheet. Alright, down here. Again, this was pulled right out of the book, but I just want to explain it. I know you can read it in there. Alright, this is a matrix equation, and again, what we're going to do, we're going to have different right-hand sides here for B. So that way, if we find A inverse once, then we can take A inverse times any of those B's on the right-hand sides and have our answers. Alright, so we're going to solve like 3 different systems here. Watch. We're going to solve this system when, here's the A that we're going to use. And it's got some fractions in it when we do the inverse, but that's okay. Here's the X matrix that we're going to use. Again, it's just going to be an X and a Y. Those variables. Again, that's a capital X. And, alright, the different right-hand sides. These are 3 different systems. We'll do one when the right-hand sides are 6 and 3. We'll do another one, 10 and 15. And we're going to do one more system, 2 and 11. Alright. So again, we have A times X equal to B, that matrix equation, where A is this every single time, times X, those are my variables, X and Y, so this is like X plus 2Y is equal to 6 for the first one. Or 4X plus 3Y is equal to 3. That's the first system. Then we're going to do it again for these right-hand sides and again for that right-hand side. Alright, but to solve this, here's my solution, all my work down here. First, we got to find A inverse. Alright, so we're going to do that first. I hope I have enough room. I think I put a couple blank pieces of paper down here, so I should have enough. Let's find A inverse. Alright, to find A inverse, if you recall, take that matrix A, augment it with the corresponding identity matrix. Right, then I'm going to do row reduction. Turn this side into the identity matrix, and then what we're going to have on the right is the inverse, A inverse. Right, so I already have a 1 here, good. I need a 0 down here, so let's take -4 times row 1, add it to row 2, and we're going to replace row 2 with that. So row 1 is going to stay. -4 times 1 is -4, plus 4 is 0. -4 times 2 is -8, plus 5 is plus 3 is a -5. -4 times 1 is -4, plus 0 is -4. -4 times 0 is 0, plus 1 is 1. Alright, that's good. Now, column 1 is straight. When you move to column 2 in the 2, 2 position, got to get that to be a leading 1. So let's take a -1/5 times row 2 for a new row 2. So we can get a 1 down there. In the 2, 2 position, row 1 is going to stay the same. And let's divide this. Here's where our fractions come in. That's okay. Divide by -5. Alright. That is what we'll get. No big deal. Okay, now since I have a 1 here, what I want is a 0 up here. So let's take -2 times row 2, add it to row 1. We're going to replace row 1 this time. Row 2 stays the same. Alright, let's see how that shakes out. -2 times 0 is 0, plus 1 stays fixed. -2 times 1 is -2, plus 2 is 0, good. -2 times 4/5 is a -8/5. Plus 1, which is 5/5, comes out to -3/5. You know, I'd sort of jot this stuff down and erase it. Right, it's just sort of my scratch work. I'm going to need that space a little later. Let's do the same thing down here. The -2 times -1/5 will be a positive 2/5, and add it to 0 is a 2/5. Alright, good. So we've got the inverse. A inverse is this. It's got some fractions in it. Don't let that scare you. They're not bad. 2/5. This is 4/5 and a -1/5. That's A inverse. So we're going to use this. Let's jump back up here and I'll show you. Remember to get the answers for x to find out our variables. We're going to take A inverse times our B matrix. A inverse times our B matrix. Alright, so we have A inverse. So times the first B. Now we're going to have x is equal to, and remember our x is that matrix x, y. Right? That's going to be equal to A inverse times B. So my A inverse, -3 halves, 2 halves, those are fifths. My bad. I wrote a 5 and said a 2. -3/5, 2/5, 4/5, -1/5. Alright, what was that first B? Just go back up. That first B was a 6 and a 3. Like that. Alright, so when we multiply these together, watch what happens. Let me try to squeeze it in over here. Alright, I'll have 6 times... Oh, let me finish this out in the next video. I'm almost out of time. I'll finish this out next one.